Check point 4. Got 3 parts to it. Part A, they want us to determine, without graphing, if the function has a minimum or a maximum value. Part B wants you to actually find the min or max and where it occurs. And then part C, give the domain and range of the function. Okay, so there are 3 parts. And so my actual function is f of x is equal to 4x squared minus 16x plus 1,000. So, what's the answer to A? Positive, so it opens up, so it's a minimum point. Now, I want us to actually find the minimum or max and where it occurs. So what am I actually finding when it asks for that? Everybody needs to hear this answer. It's the vertex. What you are finding when I give you min and max problems, and there's a whole bunch of application problems in here, if it wants the minimum or the maximum, you've got to find the vertex. That's what you got to do. There are several ways to do that, but if they give this problem to you in general form, then the easiest, quickest way is to use the formula negative b over 2a to find the what? The x-coordinate of the vertex. So you can call it h if you want to, since we were calling it h earlier instead of x. So in this case, that would be the opposite of negative 16 over 2 times 4. Okay, the negative sign's already in the formula. B was negative 16. Everybody see that? And 2 negative signs sitting right beside each other make it positive. So I've got 16 over 8, which is 2. Now, 2 is one of the answers here. Which one is it? It's the H. It's the where it occurs. Okay, it happens when x is 2. Now, the other piece of that number 8 says it wants you to find the actual minimum or maximum. So how am I going to do that? You have to find the k. And how do I do it? Plug the x back into this equation. So I'm going to find 4 times 2 squared minus 16 times 2 plus 1,000. So 2 squared, remember to do squares before you multiply. So 2 squared is 4, so I've got 4 times 4, which is 16, minus 16 times 2, which is 32, plus 1,000. So that's a negative 16, and a negative 16 plus 32 would be 984. Yes? Okay, so that's my actual maximum value, minimum value. Now, part C. Talk to me about the domain and the range. Think about what it is. It's a parabola. Got this minimum point, and it opens up here. What's my domain? All real numbers. Excellent job. And how do we notate all real numbers in interval notation? That's what we use in this book. From a negative infinity to a positive infinity. Okay? Now, what's the range? What's the range? From the vertex to a positive infinity. Because we just said this was a minimum, right? So that's the smallest number I can have, and it's going to keep going forever. Oh, let's see, better include that since that's actually a point on the graph. Okay. Just fix that. So you don't have any questions later when you look at it. Okay? So if it's a minimum, then that number is going to go at the beginning of the interval. If it were a maximum, it would go at the end. Okay? So any questions about that? The last objective in this section is just a whole bunch of application problems. There are several types of problems where we do applications with this type of idea. On page 331, it talks about the path of an arrow. If you think about the path of the arrow, what happens with the arrow? It goes up, and then it comes back down, right, because gravity's pulling it. So it gives me the model for that, which is that f of x is equal to negative 0.005 x squared plus 2x plus 5. So part A, what is the arrow's max height? And how far from its release does this occur? So what do I find? What's it asking for? Maximum, which I find how? By finding the vertex. Exactly right, by finding the vertex. So I'm going to find h. So I've got negative b divided by 2 times a. So that's negative 2 over negative 0.01, which is a positive 200. Anybody like typing that in, huh? It's 20. Probably right. That's what I thought it was at first, and then I second-guessed myself. It is 200? Oh, okay. All right, so 200. Now, that is what? That's the x. So that's this part. How far from its release? Okay? Then what's the maximum height? How do I find that? I need f of 200, right? So somebody, I'm sure, is going to plug that in their calculator for us. $205. Okay. Any questions? Okay, we good? All right. Your homework is on page 334, and I want you to do 3 through 72 multiples of 3.